Hello, this is Mr. Stansbury. I'm going to take you through the 15G assignment. All right, so we'll start with number 1 here. Write the following arguments in symbolic form. All right, so whenever you have these two lines added together, these are always connected with an and then this line here is the implies. So with that in mind, we can just do, we've got P implies Q and not Q all implies not P. Okay, so that would be this one here. All right, B, we've got P or Q and not P all implies Q. Okay. Construct two tables for each part in question 1, which of the arguments are valid, and then write the following arguments in symbolic form. So let's do the truth tables here first. So we've got everything's P's, Q's, we have no R's, so let's just do P and Q. So this is true, false, true, false. And this is true, true, false, false. Okay, so let's do this top one here. So we've got P implies Q. So that's going to be, that's the first one is this one, the second one is Q, so we're just going straight across here. So if you have the ingredients, you make the best cookies. That would be true. Sorry, this is all going off of the P is if you have the ingredients, and then Q is I can make the world's best cookies for implications. That's our easy way to try to understand this, hopefully. If you have the ingredients and you make awful cookies, then that is false. If you don't have the ingredients, you can't prove or disprove anything, so you have to assume that it's true. Don't have the ingredients, so you have to assume that it's true. Okay? So, let's see. So now we need to have, we need to figure out not Q. Alright, so not Q is just going to be false, true, true. And then we have to do P implies Q and not Q. So P implies Q and not Q. So that's this whole top part here. So that's this, and since it's the and, they have to both be true. So this first one is false, false, true is false, true, false is false, and true, true is true. And then let's see, we're going to eventually need not P. So let's see, P is true, true, false, false. So now it is false, false, true, true. And so now we can finally do P implies Q and not Q, and that all implies not P. Whew, that's a doozy. So let's see that for this one here, this is the first and this is the second. Okay, so this is the original, this is the if, and this is the then. So if you don't have the ingredients, you have to assume that you can make the world's best cookies. You can't disprove anything. So again, if you don't have the ingredients, you have to assume it's true. We don't have the ingredients, have to assume it's true. Excuse me, we have the ingredients and we make the world's best cookies. That is also true. So here is part A. All right, and it says which of the arguments are valid. This is a valid argument because it's all true. It's all tautology. Okay. All right. Let's see. We're not doing B or D. We're just doing A, C, and E. So let's get rid of those. Okay. Let's move on to C here. We've got P or Q. So if we got P or Q, that either one of those has to be true. So the first one is true. True, false is true. False, true is true. And false, false is false. Okay. So then now we just have P or Q. Does that imply P? Or it does imply P. Okay. So that means first one is P or Q, and then the second one is P. So we have the ingredients, we make the best cookies. That's true. We have the ingredients, we make the best cookies. That's true. We have the ingredients, we don't make the world's best cookies, so that is false. And if you don't have the ingredients, you have to assume that it is true. This would not be valid because it is not a tautology. It's got a false in there. So C would not be valid. All right. Number 3, P, X is a prime number, Q, X is an odd number. Write the following in symbolic form. Okay, so let's do that for A. Oh, let's change back to blue here. Let's see. All right, so X is an odd number and X is a prime number. So odd number is Q, so we've got Q, and X is a prime number is P, so it's Q and P. Okay. B, X is not a prime number, so that's P. So that would actually end up being not a prime number, so it's not P. P, it's raining. Q, I wear my raincoat. I am not wearing my raincoat, therefore it's not raining. Test the validity of this argument. Give an example that makes the statement invalid. Okay, so just put a table in here so we can test this out. So we've got P and Q. All right, so this is true, false, true, false, true, true, false, and false. Okay, so it's raining is P, I wear my raincoat is Q. So I am not wearing my raincoat. So officially this argument is going to be, let's see, not Q. Therefore, it is not raining. So we've got not P. Okay, and the therefore is the implication piece. So we've got not Q implies not P. So let's do not Q first. So true, false is now false, true, and then not P is false, false, true, and true. So now we have to do not Q. Does that imply not P? All right, so not Q is first, not P is second. That's the if and that's the then. So let's test that out. So you don't have the ingredients, you have to assume that it's true. You have the ingredients, you make the world's worst cookies. That's false. You don't have the ingredients, so you cannot disprove anything. You have to assume it's true. Have the ingredients, make the best cookies. That is true also. Okay, so we've got our truth table now. Okay, so test the validity of this argument. This is not valid because, again, it's not a tautology. So now this is a good question here. It says test the validity of this argument. We did. It's not valid. Give an example that makes this statement invalid. So the thing that makes this statement here invalid is this piece. All right, so what we have to check is we have to check not Q and not P. So the one time that it's false is when not Q is true, and then that's also when not P is false. Okay, so not Q is, so I'm not wearing my raincoat. I'm not wearing my raincoat. Okay, and then it says, and not P is false. So if not P is false, then what that really means is that P is true. Oops. Sorry about that. P is true. Okay, so P is it's raining. So I'm not wearing my raincoat and it is raining. Okay, so that's an example that makes the statement invalid. So it's raining and I'm not wearing my raincoat. All right. Okay, let's try, which is number 5. Determine the validity of the following arguments written in logical form. Okay, so We've got B and D here, so we've got P's and Q's, so let's do P. Oops, let's change that back to blue. So we've got P and Q. Okay, so we've got true, false for Q, and then true, false for P. Okay, so let's see, we got P implies Q is the first thing we need to do for B. So we got P implies Q. So that's the first, that's the if, that's the then. So you have the ingredients make the world's best cookies, that's true. Have the ingredients make awful cookies, that's false. Don't have the ingredients, you can't disprove anything. Don't have the ingredients, can't disprove anything. So there's our P implies Q. Okay. Then we also have to have and, not Q. So let's do not Q first. So not Q, if it's true, false, is now false, true. Okay. So now we can put in P implies Q and not Q. Right? That's this part here. So that's this one and that one. So these have to both be true since it's and. So we got true, false is false. False, true is false. True, false is false. True is true. Okay. Now we have to figure out if this whole thing here implies P. So we've got P implies Q and not Q. Does that all imply P? So here's where we get to finally figure out if this is determine the validity here. All right, so P implies Q and not Q. There's our first argument. And let's get rid of those. And then that's the if part. And then the then is the P. So there's our second part. So if we don't have the ingredients, we can't disprove anything. So that makes these first three all have to be true. And then the last one is true. You have the ingredients, and false. You make the world's worst cookies. So this would be false. So determine the validity. So this one is not valid. Okay. All right. Let's do number 6. Show that the following are invalid arguments. Okay. So it's just more truth table stuff. So we've got P and Q. All right. So let's see. Q is true, false, P is true, false. All right. So P implies Q is the first thing we want to do. Right, so here's the first, here's the second. You have the ingredients to make the best cookies, that's true. Have the ingredients to make awful cookies, that would be false. Don't have the ingredients, can't disprove anything. Don't have the ingredients, can't disprove anything. Okay, so there's P implies Q. So now we want to do P implies Q and Q. Okay, so now we've got P implies Q and Q. So these two things, since it's and, they have to both be true in order for it to be true. So we've got true, which is true. False is false. True is true. False, true is false. Okay? Okay, and then now the last part here is to make this whole thing here. Does that imply P? So we've got P implies Q and Q. Does this all imply P? So here is the answer part here. So let's do this. Let's get rid of these and put in P implies Q and Q. So this is the if part of the if then, and then P is the then. So if you have the ingredients and you make the world's best cookies, that's true. If you don't have the ingredients, you can't disprove anything, so you have to assume it's true. If you have the ingredients and you make the world's worst cookies, that's false. And if you don't have the ingredients, you have to assume that it's true. This is not valid because it's not a tautology. It's this F is making it so that it's invalid. Okay. The next number 6. Which of the following pairs are logically equivalent? So we've got P's and Q's. So let's start off making our P and our Q table here. True, false, true, false, true, true, false, false. Okay. Let's see. So we've got P implies Q is the first thing we're going to do. So P implies Q. So that's first. That's second. Have the ingredients make the best cookies. True. Have the ingredients make awful cookies. That's false. Don't have the ingredients, can't disprove anything. Don't have the ingredients, can't disprove anything. So true, false, true, true is P implies Q. Okay. So we want to see if this one here is logically equivalent to not Q implies not P. So let's do this. Let's do not Q, and we'll also need not P. So let's do those two. So not Q is false, true, false, true. Not P is false, false, true, and true. Okay, so then let's do not Q implies not P, and then see if these two match. Okay, so not Q is our if, not P is the then. So you don't have the ingredients, you can't disprove anything, so you have to assume it's true. You have the ingredients, you can make the world's worst cookies, that is false. Don't have the ingredients, can't disprove anything, so you have to assume it's true. You have the ingredients, you make the best cookies, that is true. Okay? So now, we are now comparing these two to each other. So in looking at these, we've got true, false, true, true, and true, false, true, true. So for A, which of the following pairs are logically equivalent? A is logically equivalent. Okay? Because they have the exact same true, false, true, 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 false, true, true. Okay? All right.